Hello. As usual, after a test, I will go through the video with my student on the question. So here we go. We got, first of all, we have a transformation function. Transformation of a, so we want to go through the question. So first of all, write down the value, which is write down the value of what you see from -2. So which means that fx is equals to this. So we mean that x equals to -2, y equals to what? aka that's what it means. So we look at x equals to -2. When x is -2, y is 0. So all I need to do is like f -2 equals to 0. Nice and easy there. So and then we want the inverse. Write down a range of inverse. So in your mind, range of inverse, so we will have a table there, remember? We will have fx domain, f inverse, range, and the vice versa because they interchange. So we have the, so the angle is here. So range and domain. So with that in mind, range of f inverse means that aka domain of fx. And all you need to do is like look at it here. So make sure, so we will have the -4 to 3. It's asking for the range, so we'll have the y there. So it's easy, another 1 point. State says on the same diagram, sketch the graph. So it's like 2x plus 2. We have to take that first because x plus 2. We have to rearrange that. That means that it's like a horizontal stretch by horizontal stretch. This is 2, therefore it's by 1/2 because inside is always negative, opposite what we want them to do. And plus 2 means left, and then left 2 units. So let me clean the diagram a bit. Oh, we are using Pilot eraser here. Can you see that? Anyway, and my Blackpink, sorry, not Blackpink, Blackwing. This is limited to 100. Anyway, so we have the exchange. So whenever it's -4, I will have -2. Whenever, and then I have to move it 2 units to the left. So -4, horizontal stretch by half, and then move 1 unit on the right. So it's here. So, and then 2 left, and then we'll from 2 to 1, and then move 1 unit is 2. So this should be here, and then the middle bit should be somewhere in the middle. All right, vertically doesn't change, just horizontally. So original is 1/2, and then move 1 is here. So it's like straight line. Last but not least, we need to take care of the 2 doesn't change, so it's still 2, but it's some 0. It moves 1 unit. 3 by half, move 1, so it's here. So it's like I should have some shape like this. Okay, that will do. So this is another 3 points for those. I hope you like this transformation, and we go to the next question in the next video. Oh, so we come to question 2 here. This is one of my favorite questions because it's pretty straightforward. When I see this a kind of exponential function, I would think of, look at that, 4 and 8. So it will be something like 2. So what first thing I would think of, like from 8 to the power 2x plus 1 equals to 4, 5 minus x. I'm doing it slowly, step by step. But if you still think I am a bit too fast, so you can leave a comment and I can explain a certain step. But then if you think I am too slow, you can always go to the speed button. All right, so we have to change the 8 to 3 to the power 2 to the power 3 and 2 squared for the 4. And then I expand that because we will have a n m should be equals to a n times m. So I multiply all those there. So we have 3 and then plus 3 equals to 2, 10 minus 2x. Careful, there's a common mistake that we missed out one of those. Now with that, we are not canceling the x, but we are just comparing the index. I repeat, when each of them, each side got one term only and both have the base 2. So we are comparing the index. All right, now it become a linear equation. I can just rearranging it. It's to 8x because I put this on the other side and this one equals to 7. X equals to 7 over 8. And we got our 8 points. Wow, so cool, less than 1 minute. So that's it. I'll see you the next question on the next video. All right, here we come to our question 3. This is a quadratic and linear equation there with a bit of the sketch. Sketch what? Let me get my ruler. Always have a ruler when we sketch equation. So there we go. We have the equation written there. Axis of symmetry is the midpoint there. I do not see the point, but I can see the root is 1 and 2. So the axis of symmetry should be 1 plus 2 divided by 2 equals to 1.5. Before we leave the question, think about that. A is the equation of, so make sure you write down x equals to 1.5, which means that this vertical line here. Careful with those. And I sketch gx equals to 2x minus 2, so I apply this 4, so this is y-intercept. And this is the gradient, which is 2 rise over 1 run for that one. But careful with the scale. When we have those, we also have to consider the scale as well, because one grid doesn't always equals to 1. So we got that. So we have when x equals to -4 for every 1 walk, 2 rise. Every 1 walk, 2 rise. Now I have my very local traditional ruler there. There we go. We have our line there, which is pretty. Use algebraic approach. Find the coordinates. Coordinates is 2 points. So we need to find that. So we will have to fx equals to gx to find the x there. So we will have the copying the equation. Zoom. Thank you. Copying the equation first. X squared minus 3x plus 3 plus 2. And then they have the equals to 2x minus 4. So if you could rearrange that, you will have 2 whole x squared minus 5x minus plus 6 equals to 0. It's a non-calculator paper, so we will have to do the factorization. 3 times 2 equals to 6. This is a negative, so I'm negative 3x and negative 2x give us negative 5x. It's a match. So I have my quadratic. So we have x plus minus 3, x minus 2 equals to 0. X should be equals to 3 or x equals to 2. We have to put it back to find the y coordinate, right? So you will have 2 choices. You put it in this side or this. Both will give you the answer. However, I'm a lazy person, as you always know that. So what I'm going to do is I put the x into the linear equation. After all, they should be equal anyway. So we will have 2 times 3 equals to 4. 6 minus 4. 6 minus 4 is 2. And y2 times 2. I need to work by presentation. Minus 4. So 4 times 4 equals to 0. And it's not finished yet because it's not a coordinate. We just find out the x and y. A lot of my students lost some points for it and they are very painful with those. All right. So this is our quadratic equation. And until next video, we'll go on to the next question. See ya. Yay! This is us again, Bonnie again. We're going to solve this equation here. So I left log equation just for your information. Other than Blackwing, I like algebra actually. So we have the question here equals to 8 log x2. So I'm going to break this 4x array. So I will make it become log 4 plus log 2x. Right? The other side, I will make it become 8 log 2 over log 2x. Now, this is based on the log A plus log B equals to log AB, just in case you don't know. And the other one is the change of base, log AC equals to log BC, the above, outside, over, inside. So this is how we're going to do it, and log 2 is 1, so we can rearrange that. Now I have 2 plus log 2x equals to 8 log 2x. Personally, you can keep it like this, but then the log 2x annoys me, so let me change it to something else. Now I will have 2 plus a equals to 8 over 8. Wait a minute, this is our kind of very classic quadratic equation. So we could have 2a plus a squared equals to 8. Rearranging a bit, 8 squared plus 2a minus 8 equals to 0. Then you can do your quadratics. A times a equals to a. 4 times 2 equals to 8. 1 must be negative, so this is plus. So the larger one is plus and minus. So I have plus 4a minus 2a gets to a 2a is a match. So a plus 4, a minus 2 equals to 0. A equals to 4 or a equals to 2. Sorry, negative 4. Be very careful, boy. Yes, ma'am. Oh, so we got that. And now we could change it back to log 2x equals to negative 4. Log 2x equals to 2. Now we could form that when ax equals to n. So log a n equals to x. So we're just rearranging that. So we will have 2 negative 4 equals to x and 2 squared equals to x. Make it nicer, equals to 1 over 16 and x equals to 4. Voila, we got the equation here. See? I loved it. Do you? All right, we will have to wait for the next video for the next question on the task. All right, I'll see you then. Hello, this is another question with my black wing and my eraser. This one, my eraser. And my long question, this one. I don't really like this one a lot because it's long question and it's transformation, but we still have to do it, so let's stick with it. At least this is a quadratic, so I'm happier. So first of all, this question asking you, giving us a quadratic equation, and this is a point. So we need to show that the k is 7. So you should be writing in the box down there. But yeah, I want to be closer with the question. Just allow me to do that. So show that 7 is what I need to do is just substitute the x and y in there. This is x and this is y. So you substitute that in equals to, so we will have 6 equals to negative 3 squared plus k3 negative. So you need to rub that off, become minus. And then plus 18. Then you get 6 equals to 9 minus 3k plus 18. So we arrange everything to the other side. You will have 3k equals to 21. So k, it has to be equals to 7. If you have no step, but just tell me that k equals to 7, you will not get any points because they already gave you the answer. So without the when the answer is already given, we don't need that. My finger is fat. Okay, so sorry. Oh yeah, they look fat here. I'm sorry. Okay, to describe the transformation from this to this, when we need to find the transformation, especially translation, we definitely need to, for quadratic, it will be suggested to use completing square, which is the vertex form. So y equals to ax minus h squared plus k. That will allow us to see the stretch and the what's that called? And the translation. So you need to do it here. So gx equals to x squared plus kx plus 18. This is the question, but I have the k now equals to 7. So there we go. We got the 7 there. So what we're going to do is like we continue with the base. So we put it into plus 2 times x times 7 over 2, that balance the 7. And then now I need 49 over 4 because this is the square to complete it. But this come from middle of nowhere, we need to minus that. And then we got 18 just coming back from there. Now this is completed. So we have x squared. I need more rooms. So we will need to have x. Okay, that's better. X plus 49 over 4 square. Oh no, 7 over 2. This is the square bit. AB. So AB. So 7 over 2 square minus 49 over 4 plus 18. To do a bit of the math there, we will get x plus 7 over 2 square minus 23 over 4. Now, all we need to do is like writing the translation. Because it's plus, it's going to positive. So this is going to the left. So shift 7 over 2 to left. And 23 over 4 downwards because it's minus. Oh no, it's plus. 18 is plus. So upwards. Sorry, my bad. Upwards. If you're familiar with the factor notation, you can write like this as well. Left, so negative 4 over 2. And upwards, 23 over 4. So it's x direction, y direction. So that is how we go through the second part. Next, we're going to have the transformation there. So let's do the transformation. Translate, follow, and then the scale factor. Then I need another page here. Voila! Okay. So we will have the gx to h. So gx is here. This is our h. Let's see. Minus 8. So it's y. So I'm minus 8 first. And then stretch by half. So I will have g 1 over 2. Step 2. Steps to 1 over 2x. Yeah? Minus 8 is still there. And then, excuse me, and then vertical stretch by 4. So I multiply everything by 4. And then reflect along x equals to 0. X equals to 0 is the y-axis. So it's the minus outside, minus inside. So we have 4g 1 over 2 negative x minus 8. Oh, painful. So now we can put it into the equation. We could have a minus should be outside. Yeah, outside. Because it's after. So now we could have our equation. Painful. Minus. What? Actually, maybe let's do it step by step. That will be less painful from there. So, yeah, let's do this. Not perfect, but that will be easier. So, I need our equation back. Let's rewrite it. Gx squared, gx equals to x squared plus 7x plus 18. All right, and then now we have to do it one by one. Minus 8, so translate. So now we have x squared plus 7x minus 8 plus 10. And then followed by, sorry, didn't see it. Let's do this here. And then followed by a horizontal scale factor. So it's 1 over 2 x squared plus 7 times 1 over 2 plus 10. So now I have 1 over 4 x squared plus 7 over 2x plus 10. Then we do another thing, scale factor by 4, the whole thing multiplied by 4. So now I have x squared plus 14x plus 14. Last but not least, we reflect x there, so we're going to flip the x. So negative x all squared plus 14 negative x plus 40. Now our equation come out. Oh, that's a pain. So that's a painful bit, but then if you do it step by step, it's not too hard. Okay? Sorry, that's a bit of a hiccup there. All right, and last but not least, we got another one. From 36, we do the translation from that. So you can plug it in, but I won't. I will say thinking of negative 3, 6. I do the same rotation again, depends on which one we do. So first of all right, that will be easier. Lucky. I do not need to recycle those paper. Oh, so we start with minus 8, y minus x. So that becomes negative 3 minus 2. All right, and then stretch right, horizontal stretch, so x times 2. Negative 2. And then vertical stretch, y times 2. Right? And then reflect along x-axis through the x-coordinate flip. So it's 6, negative 8. Oh, actually, it's not that hard, just a bit annoying there, and the algebra needs to be strong. So this is our quadratic transformation long question. Oh my God, this is a long question. 12 points. So well done, guys. And we got another 12 point in hands. Until next video, we work on the next question. Thank you. Oh, wow. This is another cool question here with my black wing pencil and my OK eraser. Actually, this is pretty good. Anyway, so let's get started with this. So this looks a bit annoying, but then, yes, that's the trick on it. That's another 12 points algebra question, which I really like. So first of all, show that, given this, show this. So what you need to do is rearrange this look to become this one. Because it's showing the whole equation look at you can throw things on each side. So let's do it. Ex1 over E2, 1 minus 2y equals to E. All you need to do is change everything with the same base. So I have E negative 2, 1 over 2 y. This is still there. Leave it. Remember, if we do not write anything out of index, it means there's the 1. So now I will have the x plus minus 2 plus 2y should be equals to E1. Just like the question in a few times before, we compare the index. So now we have x plus, not plus, minus 2 plus 2y should be equals to 1. Now, if you throw everything on one side, you will get the answer there. Oh, I forgot to multiply by 2 here, so it should be 4. Very careful. All right, now we throw everything to the other side, so 3y minus, and that is 3. So yes, that get back our question. So easy, 3 marks. Then the question asks you to solve this two simultaneous equation, which they give us this. So when I look at the question, I say, wait a minute, this look like this. So actually means that I can replace the whole thing by this because we have already proved it at A. Oh, do remember, even when you cannot prove it, you can use it in B. It's allowed. It's legal, actually. So now I will have my new equation, x equals to 3 minus 4y, and 3 over x plus, not plus, equals 1 plus 1 over y. Right? Because x is here, I'll use the method of substitution because that might be easier. I do not have much work to do here. And then I simplify that. Now I put this on that side and this on that side. So I have 3y equals to y plus 1 and 3 minus 4y. Yes, I have to expand that one. So I have 3y on this side. I have 3y pointing at it minus 4y squared plus 3 minus 4y. And then if you rearrange it, I'm running out of space, so I need the next page. So now I'm going to rearrange it. So I will have this 3y gone, and then I will have 4y squared plus 3 plus 4y minus it. Plus 4y minus 3 equals to 0. Then if you factorize it, we have 4y and y here, and then we have 1, 3. No, not this way, the other way. So we have 1, 3, negative, negative. No, 2, 2 will work. 2, 6, 6 minus 2. Okay, so 2, 2. And then this should be minus and plus. Yes. So now I have 2y minus 3 and 2y plus 1. So 2y minus 3 equals to 0, 2y plus 1 equals to 0. So y equals to 3 over 2 or y equals to 1 over 2. But we haven't finished it, so we have to put the x in. So x will be equals to one of those. So it depends on your choice. You want to substitute in this one or this one. But I will substitute it to x equals to 3 minus 4y. So x equals to 3 minus 4 times 3 over 2. So this cancel out. So it's 3 minus 6 is negative 3. No, it's 3. It's 3, 9. 9. Oh my God, it's 9. Because this should be negative. Yeah. Plus, minus. So the 1 is minus. Oh, I got the minus plus wrong. Oh, we need to be very careful. So this is negative, become plus. This is 6. Okay. Let's fix this. And then the other one, we have x equals to 3 minus 4 times negative 1 over 2. Positive 1 over 2? Positive 1 over 2. So that is 2. So 3 minus 2 equals to 1. Now we will have the equation x equals to 6. Hang on. Something is not right there. No, this is 9. This side is 9. Hiya, Bonnie, be careful. So this is 9 there because that is 2 times 3. Hey, whoa! 2 times 3 is 6. Negative 6 minus 6. Oh, God. X 6 and y equals to negative 3 over 2. And we have x equals to 1. Y will be equals to 1 over 2. If you interchange the pair, you will be, actually the boss will be upset and you will lose point. Alright, so that is how we do it. And thank you very much for we have done the paper 1 here, and then we could get on to the paper 2 soon. Thank you.